All right, we are looking at Chapter 8, Section 2 today. This is just the first part of Chapter 2, which hopefully should be mostly review for you, which is the Pythagorean Theorem. In fact, we've talked a lot about this section already in those pre-work that we did to Chapter 8 last week. So Pythagorean Theorem, the part that I try to stress over and over again is this is in a right triangle. This is not always true, but it is true in right triangles. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. You will remember it probably better as a squared plus b squared equals c squared, where c is the hypotenuse. Just a quick reminder here, a hypotenuse is always going to come across from the right angle. So in this triangle, C is the right angle. Across from angle C is side C. And similarly, across from angle A is side A. Across from angle B is side B, right? But across from the 90-degree angle is going to be the hypotenuse. We know that, again, because if it's a right triangle, the right angle is the biggest angle. Across from the biggest angle in a triangle has to come the longest side. Similarly, in a triangle, across from the smallest angle is the shortest side. Right? A Pythagorean triple is a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. So we have a few examples of these. I think we've talked about this just a little bit already, but probably the most common Pythagorean triple, that the most well-known one is 3, 4, and 5. In fact, I think I've read that the 3, 4, 5 was actually used to help architects and builders in BC, before Christ, to actually make the corner of a building. They would use a rope. I believe that would have 3 lengths on the rope, a length of 3, a length of 4, and a length of 5, with knots at 3 feet, not necessarily feet, but at 3 feet, and then another 4 feet, and then at 5 feet. And that way they could actually form this triangle using rope to be able to create a right angle for their corner. We do have a few other ones as well. So we have a 5, 12, and 13. Again, what this means is that 5 squared plus 12 squared is equal to 13 squared, right? 8, 15, and 17. Again, 8 squared plus 15 squared is 17 squared, and 7, 24, and 25. One more time, 7 squared plus 24 squared is 25 squared. Now, there is an interesting thing about Pythagorean triples in that they are actually, once you have one, very, very easy to come up with other ones. So we're going to do that just off of our 3, 4, 5 and see if we can catch what we're doing here. So 3, 4, 5, again, is a Pythagorean triple. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, which is 5 squared. So another Pythagorean triple, but it's actually the same one, is 6, 8, 10. 6 squared is 36, 8 squared is 64, 36 and 64 is 100, which is 10 squared, right? 9, 12, and 15 is also a Pythagorean triple. 12, 16, and 20 is also a Pythagorean triple. So what you might notice is that from a Pythagorean triple, if you multiply every number by the same thing, here a 2, or here by 3, what we find is that they remain Pythagorean triples as long as their ratios remain the same. So that's something interesting. That would work for 5, 12, and 13 as well. So 10, 24, and 26 is also a Pythagorean triple. I guess the last important thing here to point out is that these have to be whole numbers. So Just because three numbers fit a squared plus b squared equals c squared does not make them a Pythagorean triple. They have to be numbers that don't have decimals. All right, these are just using the Pythagorean triple to find the third side. So what you need to be able to do is just be able to tell what C is, what side is the hypotenuse, which side is the long side, what are the two legs. So here we have our right angle. Across from it is the hypotenuse, that is x, and then 13 and 23 are our two legs. So we have 13 squared plus 23 squared is x squared. 13 squared plus 23 squared. Now, I don't really care what each of those are. I don't care what 13 squared is or 23 squared is by themselves. I really only care that they are 698 when you add them. Equals x squared, and we're going to take the square root of both sides. And get x is the square root of 698. Now, 698 does look like it's divisible by at least 2. But after that, we get 349, and if it's divisible by something else, it's not easy. And so it looks like 698 is our answer here. So in other words, state whether the sides of the triangle form a Pythagorean triple. The answer is no. We know it right away because there is not another 2, right? We can divide it by 2 once, but no matter what, this is going to end up as a radical with at least a radical of 2. So we can stop, right? Not a Pythagorean triple. After this, I'll probably just write no. All right. On number 2, we have our right angle. Across from it is the hypotenuse. That has to be the long side. That's the side that goes by itself in the Pythagorean theorem. So we have x squared, which is a side, plus 21 squared equals 34 squared. 21 squared is 441. And 34 squared is 1156. If we subtract 441 from both sides, we get x squared is 715. Taking the square root of both sides, we should notice that 715 does indeed have a factor of 5. But when we divide by 5, we get 143. 143 does not have another factor of 5 in it. Therefore, even if we could simplify it, which I don't think that we can at all, it is definitely not going to go to a whole number. I said I'm going to be a little bit lazier here. No, this is not a Pythagorean triple. I'm just going to write no. All right, number 3 here, a little bit trickier. It does actually, to do it, you might not think of this, but to do it correctly, you should be thinking about what point this is and what point this is. So first of all, we should notice that this is a isosceles triangle with the two sides congruent, and that means that these two angles are congruent, and they have the right angle. So these two triangles are actually congruent. The one on the left and right, or top and bottom, however you want to look at it. That means that this point is on the perpendicular bisector, which means that these two parts are congruent. It means the length here is 9. So we might pull that out and look at just that right triangle with 9 and 26. And we're looking for x. So here, notice 26 is the hypotenuse. So we have x squared plus 9 squared equals 26 squared. X squared plus 81 is 26 squared. 26 squared is 676. Subtracting 81, we get 595. Again, clearly divisible by 5. However, we get 5 and 119. 119 does not have another 5 in it. 95. And so this is again no. So you might ask, when will it be? Well, if we had a triangle with, say, right, if we had 3 and 5, we would have 3 squared plus x squared equals 5 squared. 9 plus x squared is 25. X squared is 16 when we subtract both sides by 9, and then x is 4. Technically, x is plus or minus 4, but since we're dealing with a triangle, we know that the length has to be a positive number. So x would be 4. We'd have sides of 3, 4, and 5. This would be a Pythagorean triple. All right. The suggestion here is to use a Pythagorean triple to find x. If you don't, even if it asks you to in the homework, you can just use the Pythagorean theorem. I am going to show you what it means by using a Pythagorean triple. So what it means is that both of these two things have something in common. This is 9 times 3. This is 9 times 4. We just talked about this Pythagorean triple. We have a 3, 4, 5 Pythagorean triple. So to make this side, we have to do 9 times 5. So again, 9 times 3, 9 times 4, 9 times, and this triangle, this Pythagorean triple has to be 3, 4, 5. So we know that x is 45. You don't have to like that. You don't have to be able to do it that way. Just showing you that it does work. You can do 27 squared plus 36 squared equals x squared. And if you do that, I'm not going to do the work for you, but you would get x is 45. All right, for the second one here, again, we'd be looking at what these two things have in common. And I believe it's 8. This is 8 times 17, 8 times 15. So we need 8 times some number here. So what's the Pythagorean triple with 17 and 15? Did I write that one down? Yes, right? So 15, 17, the other side must be 8. So we have 8 times 8. So again, recognize the same multiple on all of these, and then we have a Pythagorean triple of 8, 15, and 17. Which means that x is 64. Again, if you don't like that, you can just solve using the Pythagorean theorem. That's x squared plus 120 squared is 136 squared. Again, if you do that, you will get x is 64. But again, I'm not going to do the work for you there. You should be able to figure that out. Homework, page 551, numbers 1 to 3, 9 to 11, 15 to 18. Unlike the assignment that's due from yesterday, Wednesday, to today, Thursday, due at noon, depending on when you're watching this, so it'll be a little bit awkward probably. This one is due tonight. At 8 p.m. This is your homework slip, or is your homework, so you won't have any homework more to do than this for tomorrow, but it is also your attendance for today. So make sure that you do it. If you do have any questions, then you can join me today at 2:30 p.m. I'll be on Zoom, which is a conferencing site. On that site, you'll be able to ask any questions that you have. It will feel very much like a face-to-face conversation with me, except for the fact that you will probably not see my face. But it would be like if you came up to work at my desk, you'll be able to see me working on a piece of paper and being able to answer or ask questions, and we can do that. So for those of you that were worried yesterday in your comments about not having that face-to-face, not being able to ask questions, this is my way to try to give you that opportunity still and be able to work through that. So again, that is Zoom. The information is on the instructions page for today, so you can find the login information there.